Today, we're going to be doing the Unit 8 test review over exponential functions. Fun, fun, fun. Okay, on number 1, we've got to write the exponential equation of this problem, okay? We start with 400 ants. That's our starting amount. That 400 is going to go right here in it. Now then, remember, if you have a percent increase, you have to do 100 plus the percent. If you have a percent decrease, you got to do 100 minus the percent. Don't forget that. So right here, they are growing at a rate of 8%. So we got to take a percent increase. We're going to do 100 plus 8. You get 108%. If you move the decimal twice, that's going to be 1.08, which will be our common ratio. That 1.08 goes here, doesn't it? And then you need an x to the exponent here. So you would physically type this into the calculator. 400 times 1.08 to the x power. Okay, on this one right here, it's decreasing by a rate of 20%. So right here, I'm going to do 100 minus 20 and get 80. Move the decimal twice, that's 0.8. That 0.8 is going to be my growth rate. And then the y-intercept is 8. The 8 goes here. So I'm going to type this into the calculator and write down my t-chart. So I'm going to go to the calculator. I'm going to go to graph. And then I'm going to type 8 parentheses, 0.8 to the x, hit enter, and then I'm going to hit Control T. And then these are my numbers, okay? So 0 is 8, and I'm going to use just 2 decimal places, okay? Just use 2 decimal places. So we're going to have 8, 6.4, and 5.12. So 8, 6.4, and 5.12. Okay, remember, use 2 decimal places. So I need to get my 3. My 3 is 4.09. I'm just going to drop these. I'm not going to round them, okay? 4.09 and 3.27. 4.09 and 3.27. And then my 5th number, I'm going to go down here to get to the 5th number, is the 5th number is 2.62. Remember, I'm not rounding these. I'm just dropping, okay? So I'm going to go over here, and I'm going to graph these as accurately as I can. 0 is 8. 1 is a 6.4, which is going to be about here. 2 is 5.12, barely above the 5. 3 is 4.09. 4 is 3.27, about right in here. And 5 is 2.62, about right here. So the graph, we're doing a piecewise function here. We're going to go like this, right? So it goes from here to here. It's going down. It eventually would go down here and form the asymptote. So the asymptote is y equals 0. And then the asymptote would be like this. And then the domain, we're going to go from 0 to 5, aren't we? 0 to 5. And the range is going to go from this number to this number, right? 2.62 to 8. So my domain goes from x to x. My range goes from y to y. Okay, number 3. Which statement about this is true? Remember, this is the y-intercept. This is our growth. And the asymptote would be x equals 0. So we want to know the true statement here, okay? Okay, so we need to graph this. Let's eliminate some, okay? So right here, the x-intercept, it never ever has an x-intercept, okay? The y-coordinate is 0. That's true. The equation of the asymptote is x equals 0. The equation of the asymptote is y equals 0. And then the graph includes 25 and 26.5. Let's see if that works. So if I were to plug 25 in, I'm just going to do this on the calculator. this is saying this. If I plug 25 in, I'm going to get 26.5. That's going to be way too big. This would be incorrect, okay? So the answer is going to be D. The y-intercept is 0.25. Number 4, okay? So we have the function 60 parentheses 1.8 to the x. This is the starting amount, right? This is how many rabbits we start off with. So this is the starting amount of rabbits, and this is the growth in it. They're not going down, they're growing up. And 1.8 would be 100 plus 80, which would equal to 180. That would be the 1.8. So my percent increase is 80% in it. Now then, which one is not true? So I know the starting amount 60. I know it's growing by 80%. The population of the rabbits started off at 60. That is true. The population of the rabbits is increasing. That is true. Okay. The x-intercept, it never ever has an x-intercept. The asymptote is y equals 0. C is false, right? That's the one that's not true. Number 5. Okay. Calculate the growth of the Asperger. The city council conducts a survey. The initial population was 3,500. This number has got to be 3,500. That eliminates this choice and this choice, right? Okay, the next population was 4,250. This would be your new population, right? If the population continues to grow, what would model the growth rate? Remember, your growth rate will always be new over old. So we're going to do 4,250 over 3,500. That's going to give us our growth rate. So we got to look for the one with 4,250 over 3,500. This one's incorrect. This one's right. So D is the correct answer. This is the initial amount, and this is new over old. Okay. Number 6, fun. Okay, we're going to get these. These are our answer banks here. This is the starting amount of hay, right? And this right here would be your growth. And technically it'd be 100 plus 5 is 105. It's going to be a growth of 5% in it, okay? The initial amount of hay has 2,400. The initial amount of hay in the barn has 2,400, or is, this should be is. The hay, this is growth. The hay is increasing at a rate of 5% per week. So this one right here, you had to get the 5 from the 1.05, didn't you? It's not growing by 105%, just 5%. Number 7, okay, I know the y-intercept is 4, don't I? So look through here, it can't have a plus or minus, but this works and this works. And then it has decay, doesn't it? This is decay. That means this number has to be smaller than 1. This is growth in it. So the right answer is going to be C. If I were to graph this, it would match to this graph, okay? Number 8. On this one right here, we're going to plug in a spreadsheet, okay? So on number 8, we're going to do a spreadsheet. And then after the spreadsheet, you do menu 41A. This is statistics. And then you want to do a stat calculation. And then A is exponential. So we're going to go to our calculator. We're going to hit home. We're going to do 1 for new. Don't save anything. 4. And then you need to put X and Y at the top. Get an X and a Y at the top. And then I'm going to plug in the numbers. -1, 0, 1, 2, and 3. I'm going to go back up. Jiminy crickets. And then I'm going to plug in 320, 80, 20, 5, and 1.25. Okay, so I got my T-chart in. My blue box is an open square. I'm going to do menu, statistics, stack calculations 1, and then exponential is A. So menu 41A. Then it's the same thing. X, down, Y, down, and hit enter. Boom. This is my A and my B. So my A is 80 and my B is 0.25. So I'm going to go over here. My A is 80 and my B is 0.25. Which one matches up to that? 80 and 1/4 right here in it. Okay, the 1/4 would be my 0.25, wouldn't it? Okay, continuing on, number 9. Write the equation for the asymptote in number 6. Your asymptote in number 6 is this line. And it's going to be y equals 0. Don't forget that. Your asymptote will be y equals 0. Number 10. Okay, we have part of an exponential function drawn. We want to get the domain and the range of this. So remember to draw a box that surrounds your function. Your box goes from here to here, which is -4 to 2. So my domain needs to go from -4 to 2, doesn't it? It needs to be bigger than -4, but less than the 2. So I'm going to look at the 2 with the domain. It needs to be bigger than -4, that's right, and less than or equal to 4, that's wrong. It needs to be bigger than -4 and less than 2. C is the domain. Now then my range is going to go from -1 up to 4. So my range is going to go -1 to 4. It has to be bigger than the small number, but less than the big number. So these two have my range, and it needs to go from -1 to 4. It's not -4, is it? Or I'm sorry, this is a +1, isn't it? So it goes from +1 to 4. This one works, okay? We're almost done. Number 11, we have a sequence. This number is our first number in the series. So I'm going to start at 6, and this is what it grows by. So I just keep adding 4. That's all you got to do. So I need 6, 10, 14, 18. Right here is the answer. Where you're going to do wonderful on your test, remember to always believe. And if you need to believe, you need a Pentagon T. You're going to do wonderful. Keep believing in yourself and never stop believing.